In this video, I will show you the steps for solving absolute value equations. Now I have a couple tips here. Number one says, always isolate the absolute value expression using inverse operations. And number two, the expression inside of your absolute value symbols can be either positive or negative. And it's really important that you notice that it says inside of your absolute value. And therefore, what we're going to do is you must write and solve two equations. Now I want to do a quick reminder from the previous video. What we did over here on the bottom side of the previous page is talk about your three cases. If you have an absolute value equal to a positive, you can get two solutions from those two equations. If you have an absolute value equal to 0, you're going to get only one solution because we cannot make 0 positive and negative. Technically 0 is neither positive or negative, and so we're only going to be setting up one equation to solve. And then third, from the previous video, if you have an absolute value automatically, so right away from the get-go when you see it, if you see it equal to a negative, you will say the answer is no solution, because absolute value has to represent distance, and it wouldn't make sense to say negative distance. So I'm going to do a couple examples of each of these. So for my first example here, letter A, it says solve the absolute value equation, and notice how our number here is 5. It's positive, so I know I'm going to have two solutions, and so here's my reminder to you to set up the two equations. What's inside of your absolute value bars could have been equal to what's inside here could have been 5 or negative 5. To pop out of your absolute value bars, positive 5. So one of my equations will be that x minus 2 is equal to 5, and the other one is that x minus 2 is equal to negative 5. So notice how I'm taking the original equation, what's inside my bars, so that was inside my bars, and it can be inside 5 or negative 5 to pop out a positive 5. And now we'll just solve. So I'm going to add 2 to both sides. And then in this case, one of my solutions would be 7. And then over here, if I add 2, I get a different solution of negative 3. So those are the two solutions that if I were to plug back in, I would get 5 or negative 5. So it would look like this. Absolute value of 7 minus 2 is the same as the absolute value of 5, which is positive 5. And now if I plug in negative 3, the absolute value of negative 3 minus 2 is the same as the absolute value of negative 5, which does pop out as a positive 5. Okay, now here in example B, I'm going to set what's inside my bars equal to positive 6 or negative 6. So my 3x minus 1 could have been inside here 6 or negative 6. So that's my positive. And then my equation equal to negative 6. And now we'll solve. So I'm going to start by adding 1 to both sides. And you're actually going to do the same solving process, but notice how you'll get different answers. Here I'll have 3x is equal to 7, but over here I'll have 3x is equal to negative 5. And now if I divide by that coefficient of 3, I would have one solution of 7/3 and another solution of negative 5/3. So those are my two solutions because my absolute value is set equal to a positive. Okay, now take a look here. I'm going to show you these two examples next. Looking at your absolute value, what we need to do is isolate. Number one, isolate the absolute value expression first. And so notice how my absolute value is not isolated on this side of my equal sign. So before I set up my two cases, I'm going to add a 5, and I will have an absolute value of 2x minus 7 set equal to the number 9. Now 9 is a positive, so because it's set equal to positive, I'm going to set up two solutions. Two cases. So 2x minus 7 can either be 9 or that 2x minus 7 could have been negative 9. So do not change your expression inside the absolute value, only change the number from the outside, one for a positive, one for a negative. Okay, now we'll solve. I'm going to add 7 to both sides, and now we'll have 2x is equal to 16. And if I divide both sides by the coefficient of 2, one of my solutions will be the number 8. And over here, if I add 7 to both sides, I'm going to have 2x equal to negative 2. And if I divide both sides by 2, I get a solution of negative 1. Oh, here, let me raise that up just a little bit. Now for letter D, again, my rule that I said first, my tip was, number one, always isolate your absolute value bars. And right now, my absolute value is not isolated because of that coefficient of the 2 in the front. So what I need to do is get rid of that before I decide how many equations I'm going to solve for. So if I divide both sides by 2, I will have the absolute value of x minus 3 set equal to 2. 2 is a positive number, so I am going to set up two equations to solve. So here's what those are going to be. So I'm going to set up my x minus 3, because what's inside here could have been 2 or negative 2. So I'm going to set 1 equal to 2, and my x minus 3, that one could have been negative 2. So notice how the equation part in here doesn't change, only the number, one is positive, one is negative. Now I'm going to solve by adding 3 to both sides. And when I add 3, one of my solutions is 5. And if I add 3 for my other equation to solve, I'll get a solution of 1. If you want, pause this video and try, actually, I'll just record a whole new video. I would recommend trying your practice, class practice, E, F, G, H, I, and J, and I'll record another video for those 6 problems. So if you want, pause it, see if you can try it, and check out the next video.